Hello there, welcome back. So today I'm going to show you how to make subset of XMRG precipitation dataset if you have that in my previous videos, right? I already demonstrated how to overlay shapefile on XMRG precipitation using HEC-Grid util software. So now I'm going to show you how to make subset of your study area. If you have, because the precipitation usually covers, right, region, we don't need that wide region because it will kill our memory and the hard drive. So that's why if you wanna even make subset of this XMRG for your study area, because study area usually not that big, not that wide, so we can do that. So now I'm going to show you how to do that. You need some processing, need some scripting, and need to understand what I'm going to do. So let me just share my screen pretty quickly and show you how to do that. Okay, so here is the data I have. Previously we already saw that, right? Yeah, so I'll make subset of this watershed that is called Galveston watershed. Here you can see that is the Galveston watershed, and then I'll show you the animation as well as before. So how can you do that? So in order to do that, what I have to do, I have to generate, okay, at first I have to generate the precipitation for Harvey. So what I have done, I have downloaded this data set for Harvey here from 20th of August 2017 to 10th of September. Okay, 10th of September and 2017 and up to 23rd hour. This is hourly data. So I have the same script, but now I need to even modify a little bit of the script. Here you can see in that script, that is the main script I have. So here it is. Using this script, I'll generate that August 2017 or Harvey, okay? Harvey 2017.dss, and the grid will be SHG and site will be WGRFC, and then the F word will be precip. So what I'll do, I'm just saving this one, the script, and if I run the script, then it will generate and I'll display. Then I have to even understand the lower left corner, because this file needs the coordinate of the lower left corner and then the number of grid, because we have to pass one text file. So I'll show you that one. It is not that a difficult task, but understanding is very important here. So I'm just copying the directory where I have that XMRG, and with that executable, right, you already have the executable, so that is the executable you need, grid load xmrg.exe, and I have the script in the same directory. So I'm opening one command window there, you can see, and from that command window I'm just navigating to that directory, okay, here, and I have everything there. You can see all these files are there. And now if I just run that XMRG to that DSS, okay, so let me just check if the script is okay or not, because see, it starts with XMRG and all these files, these are also starting with XMRG, so it will cover everything there. And then I'm gonna run it and let's see, and see, I just hit the enter. Okay, it's checking if everything is okay or not. Okay, let me make it bigger. XMRG. Wait a minute if it works, because sometimes it takes time to execute. Or let me make it clear there. XMRG2 DSS, okay? It's checking and it started computing that one. See, we have everything. It is showing the href grid. If it is href, the origin will be 290 and 110. And if it is SHG, the origin will be -663 and 55, right? That will be the origin. And see, it started calculating pretty quick, and we are having that data here, see, at the same time. Hopefully we're gonna have that Harvey. See, the number is increasing, the file size is increasing there. So because we have like more than, how many files you have? I have 500, more than 530 file, because these are the hourly time step. So it is calculating for hourly, and then it will be easy to even demonstrate the real world case. So when it will be done, then I'll extract because see, I'm going to show you here that I have the study area here, and I'm going to make subset of this. I'm going to display and I'm going to cut the precipitation, the XMRG precipitation only for this area, not for everywhere, because I don't need, right, everywhere. I need only this one, this region. So in order to do that, what I have to do? In order to do that, I have to know the lower left corner, the coordinate of the lower left corner. If it is in href, so the origin, we know the main file, the origin of the main file, it is there, right? And if it is SHG, standard hydrology grid, then we also know the origin, right? It is -663 and 55. So out of this data, when I'll plot this there, I'll export the lower left corner of my study area, this study area. I'll find that from this grid util software, and then I'll do that. See, for this case, if I click there, extract tool, and if I just make a rectangle like this way, can you see that? Can you see anything there? Nothing, right? When I'll import that data, then I'll see that. Okay, so that is that. So in order to do that, other than just waiting for completion, I can even start generating, okay, start generating the grid set. So for this case, I'm generating new grid set as new. You know that, right? The previous one, I'm not gonna save anything, so I'm putting no, and then it is new here. The name will be Harvey, okay? Harvey 2017, and then this will be WGRFC and rainfall, right? So this is from West Gulf River Forecasting Center, and it is asking where I have that that DSS file. It is in my C drive, and it should be there, user, and inside that user I have that in download and XMRG. See, we have that file, and I'm putting okay, and then I'm just assigning that path as before. If you already watched my previous video, and it is hourly, so it is hourly, right? And the path name, so far I have this path name. See, it generated this path name so far. Still it is generating, but I'm closing it here, not a problem. By this time we'll have that data complete, and if I hit OK, then it's gonna add you that precipitation as before, right? You know that. And then I'll extract the lower left corner of my study area and the number of cell, because if the grid is SHG, then the cell size will be 2000 meter, and if it is href, then the cell size will be 4.76 kilometer, right? So nothing is showing up here. What you have to do, go to view layers, or you can even fix the time window, right? It is starting from, the starting date is not August 1st. The starting date is August 20, right? 20, and the hour, for this case, the hour is 00. You can use 00 hour, okay? And the ending date, if everything is okay, then the ending date will be different. So for this case, I'm gonna put it up to 30, okay, or 31st, whatever it is. And okay, 12 hour is also okay, not a problem. Then I'm just applying, it's loading, it's checking the date, starting and ending date. If everything is okay, then it's gonna show up here. See, we have the extent there. It is covering the entire region. Okay, still it is loading. You can see that it's loading the time series. You can see the time series, it's loaded there. And what I can do, because it's pretty huge data, that's why you need to make the subset. That's why I'm showing this one. If you have heavy precipitation, then the file size will be so big, your software won't respond that way, then you need to make subset. So let's try to make it bigger, the map. So here it is. If I just, because I'm using this time a different coordinate system, it is not even UTM, it is WGS coordinate system. Here it is. See, if I even move, and you can see it's still loading and running, and everything is there. And let's check. See, still it's running. Okay, not a problem. It can run, and we can do whatever we want to do here. So that is the precipitation. And if I even go to this grid and I have this value, it's okay, it is showing there because it is covering the other part, not this part. So that's why I'm just applying and map here, okay, then hit. That's that. Or we can even create our own project using UTM coordinate system. That will also help us to generate that one if we want. Okay, let me just create that one as well. Let me open my GIS, and pretty quickly I can even convert to make it even similar to our previous project I did, because I changed my computer now, so it is in different PC. That's why I don't have the previous data, so I have to even reproject whatever we had previously. Okay, so while doing this one, see, it's done. Can you see that it's done? Now let me just even open one file using that DSS view. If I double click there, see, it's gonna open the DSS view. See, the version is this one, and I have this data from September. See, this is from September. It is different, the order is not same. So I can even click and can display the precipitation. See, the precipitation and the property we have, cell size is this, and the origin lower left corner -663 and 55, and we have this number of grid along X direction, and we have 845 along Y direction. So that will cover our entire region, and you have the statistics here for that specific time period. Okay, so we don't need that one to know, but what we need to know here, okay, where is my GIS? Let's open the GIS first, and then we have this data. Still it is showing the other part of our study area, and even if I want to even remove that Galveston watershed, and then I can even change the map coordinate, and then it will display. Maybe it's gonna cover whatever we have, because I already selected this part. That's why it is selecting that one. And if I even close it, okay, and if I just save it, okay, I'm saving it, I'm closing it again. If I want to even open, because previously I mentioned that one, okay, if I open for the first time, then it will open the last project I have. So this is how we can do. By this time I can even, okay, I have 2 GIS, I don't need 2. So here it is, I can even use that. Okay, I can open anything. For example, I can open a new, okay, new template, and by default it's there. And okay, so here it is. And if I even want to open that file I have, and then I'll project it, okay, Galveston Bay watershed there. I'm gonna open it, and I'm gonna reproject it, and then I'll put it there. This is the Galveston watershed, and I'm gonna put it there. I have that, so click there on the toolbox, and you'll have access to that one. Okay, so here it is, it's opening because it is taking a while. And now we need to even know the lower left corner of this one. That's why I need to do all this processing. I'm just repeating the process because of this computer kind of thing, but don't worry, I'll do it pretty quickly. And here it is. After doing this one, I'm gonna even open when we'll be done with this one. So what do we have to do? We have to here data management projection, and then project, and it'll be there Galveston. Okay, it's just taking a while because this PC is not that fast as before. It's opening because I'm just processing all these things, even though it has big memory. And the output coordinate system will be what? It will be projected coordinate system. That's why you have to even select the UTM. Okay, UTM, if you select that way, or even you can select WGS 984 Northern Hemisphere, then UTM zone 15N. Here you can find it from this list. Okay, the datum is 1984, and it's there, and it's gonna give us this project. Here it is. And here, see, I have this everything there. I have a new, I'm gonna open a new, so it's gonna display and it's gonna done. Okay, we're done with this one. So let's create one new. Okay, new watershed, then it will be okay, means subset. Okay, subset XMRG, and description of this one will be subsetting the rainfall. Okay, and then what will the location we have to select? It is not gonna be here, it's gonna be on my previous, right, within the previous directory I have data, and then within this folder and grid util, right here we can use there, or I can create one and then grid util and subset. Okay, grid util subset, I'll put everything there inside this folder. So that's why I'm just selecting grid util subset, open, and select the time zone, select the unit. The unit will be okay, it is -6 as before, and the unit will be SI, and it is going to give us the properties, right? Subset XMRG, subsetting the rainfall, SI and GMT, everything is okay. Hitting okay. So we have the, right, what we have our project. Now what do we have to do? We have to specify our coordinate system, right? So what is the way? So here from view, map, and coordinate system, here there is nothing. So what do you have to do? Select the universal transverse marketer, everything is there. This will be WGS 1984 and zone number is 15 N, right? 15 is okay. So it's gonna give us this one. We're done with this. So now I'm just exporting. I'm gonna export this one, this data, and export the shape file, this shape file. Okay, where I have to find the location where I have this inside that map. That will be our watershed. Okay, watershed. So saving there, and I'm not gonna even show this as a layer. No, so it's already there. Now we have to import the layer. Click layer and then edit, and then allow layer editing, and then from map, add map layer. You'll have directly see access to that watershed. See, it's gonna show us here, right? So I'm done with this one. Now it's time to even generate that precipitation, and before that I'm gonna copy this Harvey, or okay, we can directly generate that grid dataset, new, and then that will be Harvey. Okay, Harvey 2017, and that will be WGRFC rainfall. Okay, hourly rainfall, just give the description because it's hourly rainfall, and then click new. It's gonna ask you the path where I have the file. It is in my C drive, and inside C drive from user, it's in my downloads. Okay, and then inside this one I have Harvey. If I click OK, I'm just selecting the path as before, you know all this step by this time, and I have this hourly data. And if I check the path this time, see I have the path 528 path because it is covering the entire range. If I hit OK, then I'm done. Okay, it's gonna store everything there. It will do that if I just specify the time window, because the time window I have from this 19th August 2017 24 hour to not 31st August, it will be September 10th. Okay, September 10, and that should be 23. That will cover the entire time. If I just apply, it's gonna load everything there. Okay, it's gonna take a while, and it's gonna show you everything. So from 19th of August or 20, yeah, see it's showing everything there, right? Now it's time to make the subset we need. Still see it's just loading everything because it is calculating the maximum precipitation for, see it's there, the time series we have. When it will be done, it is still loading. Then we'll select this rectangular region, and then we'll just extract. So we are done. So we are gonna select this one. At first I'm gonna zoom in. Okay, I'm gonna zoom in and I'm gonna select this region, this watershed. So I'm just showing how to do that. So selecting this tool, extract tool, and then I'm gonna cover, draw rectangle, right? This rectangle, draw it. If you draw, you can see the coordinate for each of this. Just write it down, right? What we have 6. It is -6 and 302, and the upper right corner is 126 and 455, right? So let me just quickly show you that. Here I'm gonna open the Excel and I'm gonna put it there because I have to calculate some values. How can I do that? So the lower left corner, the X, right? We have X and we have Y. So for X, I have -6, and for Y, what is the value of the Y? It is 302. That is the lower left corner. And then what I have, the other one, that is basically 126 and 455. 126 and 455. So now I have to calculate the number, okay, number of cell. What is the number in between? So that will be difference between these two, right? This one minus and minus this one, okay? So it will give us +1, so 133. And for this case it is same, this one minus this one +1. So we have 154 and 133. So here is the explanation. So here if I start my new region, means new origin is this one, this point, that is gonna start from -6 to 302, and it will cover up to this one. And since the grid is 2000 meter, so along this X direction I have this number of cell 133, and I have 154 along this Y direction. So this is the cell number I have this way, right? So that is the way I can just show you. So these are the cell number, these are the cell, it is gonna give us this way. I'm just drawing pretty quickly. So these are the cell. So since I'm gonna use ASCII format, and in ASCII format it is the general rule that you have to specify the lower left corner and the number of grid to get this point, right? Then it will automatically understand that, okay, this is the lower left corner and I have the number of, because the size of the grid is known, and if I know the number, then it automatically it will reach this point. Okay, so that's it. Now I know the information. I have to modify my script. So I have to use another text script or text file here, extraction. Inside that extraction, that is the explanation. So I'm specifying the subgrid name as WGRFC, and the subgrid type is also SHG because my previous grid is that one. And even if your previous grid is HREF, you can specify this one as SHG. And the subgrid version, I'm specifying, okay, previously it was Precip, now I'm gonna give the name as Precip subgrid. And the subgrid origin, what is the origin? It is -6, right? -6 and 3. And what is the, that's why I have written there, -3 and 302. -3 and 302. And what is the number of cell I have? It is 133 and 154, right? 133 and 154. And the grid cell size is 2000. You can even change the cell size as well if you want, because that is standard ArtLogic grid. You can even change it from 500, 100, even 2000, 4000, whatever it is. But for HREF, the grid should be fixed. It will be 4.76 kilometer. I'm saving the script, not the script, that is the text file. That is the property of our watershed, right? Property of our study area. So it is just assigning the boundary as coordinate. Okay, now what I have to do, I have the script that is kind of modified script, extraction. So here's the script. I'm gonna just show you. I'll run that script where I'm passing that text file here, XMRG underscore subset. So here it is. Here's the script. It is kind of same. I'm looping through each of these files here, and then same as 2000, the name will be that one, Harvey, SHG or Harvey subset, okay? Harvey subset. And then I'm using this command extract. Say extract equal to extraction.txt, the name of the text file that you are gonna pass, right? Inside that text file we have the property of the boundary, and then as before, grid will be SHG, side will be WG or FC, and then F part is this one. And here even you can assign the unit as inch or millimeter. Even you can change the unit. If your unit is that, even you can change the unit as well. It doesn't matter, okay? You can even do that, or you can even modify, or you can even use millimeter. It doesn't matter. By default it is millimeter. If you want to change it, you can specify the unit. The command is d units is equal to millimeter. It will understand, okay, you need to change it. So these are the options you have. And now if I run this script, then it will generate another precipitation.dss file that will cover only this study area. So I'll also show you that one. So that is very important, because sometimes if we have bigger region like this one and heavy precipitation and your value is too big, see the only precipitation is like 250 millimeter per hour, which is pretty big, because the Harvey, it was so big storm, right? See, if I just even make animation, okay, let me just quickly stop that and drag it there. You'll see if I can do, okay, here, if I can do that, see the precipitation, can you see that the storm is hitting? See, the storm is hitting this area, it is there. And if I just run it, okay, I'll show you that one. By this time I can even run the script, and then by this time it will do that. Okay, so our script is ready. So here I have everything ready. Now if I run that, now XMRG to DSS, but this time it will be underscore subset. If I run this one, if everything is okay, see it's running and it's gonna create the subset of your study area. So here it is, because I have like huge, so that one, see it's reading and running. So when it will be done, I'll even add that. I'll create one, another set, and by this time I can show you there. See, it's running, huge precipitation we have. See, the storm is there. There's even, see, turbulence. Can you see the storm, the precipitation? This is called Matagorda Bay. I also worked on this watershed. I'm familiar with this one, because I have, I set up HEC-HMS model for this one, and I basically use this type of precipitation for this watershed, not this one, but I'm just showing this for the sake of this tutorial here. See, it's pretty huge, right? Pretty huge. The storm is pretty huge. That's why I don't need everything. I need to cover only this area, and that is the way you can even cover everything if you want. Okay, let me just try to generate another grid set so that our task is gonna be finished pretty quickly. So here it is. I'm gonna create another grid set, new, and then okay, yes, say yes to all means it's gonna save, or I'm canceling that one. And if I just want to use new, and that is the name. Okay, so I'm gonna make the name as Harvey subset. Okay, Harvey 2017, and it will be subset. And then the rainfall, all rainfall, okay, study area, and that is gonna give us this one. And if I just want to use the same precipitation data that is currently generating here, let me check if it is creating everything pretty accurately. Yeah, of course, the file we can check. I think it's gonna finish off pretty quickly, right? And see, the previous file size was like 42. It doesn't matter, because this XMRG file, this is so effective to store data. It is just storing this data set, because these are the binary file. It is one of the best way to store this time series data. And then we also have the grid.grb, that is also binary, a gridded binary, that is another format. So that is also effective. But using netcdf file or working with netcdf files is more convenient than making time series or any other thing. But sometimes you will have this type of precipitation data, so you have to take care of this one as well. So if you then didn't watch my previous videos how to download this MRMS precipitation stage 3, stage 4, and how to process all this one, you can even check that one, because you need to even learn different types of precipitation, how to download this one, and how to even process all this precipitation data. If you are familiar with every possible product and QPE, MPE, and then everything will be easy for you. Okay, so here it is. Still it's gonna finish up, and now I'm gonna select that data, whatever we have so far we can add. Just okay, I'm just clicking, and then download, right? From downloads, XMRG, that will be the subset, this one. I'm adding this, okay? And then the path we have, here's the path, and let's check, that will be this one, not the other one, otherwise it won't work. And check the path name, how many path we have. It is like half of this one, 2, right? 52. So what is the last time and step we have here? We can check it, no problem, but I'm closing it here, and then if I click OK, it's gonna even show up to whatever we have. See here, right? We have that time, you can check that the time is there, and if I run it, you'll see what is gonna show right now. See, if I run it, it started running, and you can see we have precipitation there, but we don't have precipitation outside of this box, because we are just right extracting everything out of this box. See, now because it is at the beginning of the August 20, right? So that's why, see, we have only precipitation for this one, and it is not covering other areas this way, right? This is pretty amazing, right? Of course, because you need to understand how to do that, because it needs some insightful knowledge on that one, and the data format as well. That's why I was even exploring when I was working on this watershed, because I've learned all this thing when I was working for this Matagorda Bay watershed. And then I figured it out, and I wrote all this script, and I was reading this material, that material, and then finally I was successful. And then that's why I'm just sharing my knowledge, so that other people can understand and replicate everything, whatever I'm doing here. So still maybe it's running. See, it still is running. Whatever it is, it doesn't matter, because what I was doing previously, I was even generating this .dss file for 25 years, and it was from 1991 to 2017 or 18. It was for 25 years, so my data was pretty huge. That's why I was even not able to store all these files in a single, because in a single file, and then my model was not running. It was even showing error. It was loading and loading. It was taking too much time. Then I thought, okay, why don't I make subset of my precipitation, because I was running the HEC-HMS model for this watershed, but I don't need, right, the entire region, entire Texas. That's why I just figured out, and I just made that subset for this region. And now I'm gonna show you this one. So that's that. See, if you need to make subset, you can plot this way. And if you even miss my previous video where I just mentioned how to overlay this, right, that shape file over your precipitation in details, you can even go back to my previous, just the video I just uploaded before this one. And when you are done with this one, you can even save the image. How can you do that? But in my previous video, right, I didn't even show that how to even make plot of this one. I'm stopping there. Okay, I'm stopping there. Here it is. And okay, let me just fix the maximum. Okay, here is my maximum precipitation. Okay, and then if I want to even save it, the image I can see, I want to save it. How can I do that? Just go to File and then Save Map As. And here, if you want to even save that map, just I'm just saving there as PNG. And you have JPEG, you have other format WMF, but for this case, I just prefer to save PNG. So that is Harvey. Okay, Harvey.png. I'm saving it. It's done. So even you can export, you can do this thing. Here it is, the image I just exported. It is this one. See, it's pretty nice, right? The image is also pretty nice. See, you can see the image. It is this one. So you can fix, you can do that. See, even if you wanna exclude everything, if you want to show only this one, this watershed, because here it is showing everything, right? So how can I do that? You have to even make, so I think, let me check. Yeah, it's done. By this time it's done. Okay, so what you can do, you can even select your watershed. You can even select your watershed. How can you do that? You can select this way, selection tool, this one, right? That is called, this selection is, I select this way, and if you click even shift and then rest of the watershed, you can even select this way as well. This is one way to select anything. Okay, this is one way to select. Okay, this is one way to select some of these. Okay, this is one way to select, but there is another way. This is another way to select the entire watershed. That is called select by attribute. That is called select by attribute. Okay, here it is. Or you can even select part by part. This one, this one. You can even select this way. You can select this way. Or see, if I right click and open attribute table, that is this, but you have to even identify everything, and you can even select by query. You can select by this way. I'm just selecting, see, I'm just selecting using this one. Press shift, and I'm not gonna miss anything. I'm just selecting very carefully there, and I was missing this one, so I selected everything. Okay, and now if I just wanna export it, export this data, and it will be there, and here it is. That will be Galveston. It is called Galveston. Okay, it is Galveston watershed. Now I'll have only this watershed, and it will look good as well. I'm not gonna add it here. I need to add it there. Okay, so how can I add this layer and then edit? Okay, allow editing, and then I wanna even remove this one, right? I don't need this one. So how can I do that? And go to map and remove map layer. It will be removed from the map. Okay, there is nothing. Now I wanna add, right, the map. Just I export it, edit, and then allow editing, and then add map layer. It's gonna give you this one, Galveston watershed, this shape file, and there it is. Now we have pretty nice map, right? If you wanna even change everything, the property you need to change, go to properties, and if you even want to use only the outer color, the border will be black, and increase the weightage. So that's that is gonna give you the border. It's pretty nice, right? And if you want to even see the number, the watershed number, you can even do that here. The level, this will be watershed ID, right? You can even do that. If you apply, it will display the watershed ID you have, and even you can change everything, because this is pretty convenient, right? Levels, watershed ID, and here's the text, and you can even make it bold. You can even increase the size to this one, make it visible, and if you apply this way, see, it's gonna show you this one. And if you want to even make it bigger, you can zoom in, right? You can zoom in a little bit, or you can zoom out a little bit, and then you can even export, and you can save the map, and that is gonna be your map, and you can use that map for your report, for your other submission as well. So here it is. Okay, this time I'm gonna replace that, and here it is. See, here it is. So it's pretty nice, right? Yeah, of course, why not? So here it is. Here's the map, and I made the subset of the XMRG, and I just displayed. By this time you have idea about everything, right? So that's that. I'm not gonna even make it longer, so I'm just finishing off here for making subset of your study area. What you need to do, you need to use this tool. You need to select it, and then find the coordinate, the lower left corner and the upper right corner, and use that text file as, right, as an input for that script, where we have to pass this text file as extract, and then the rest of the right? Rest of the code will be as before. And if you run this code, and you can do that. But if you have, see, I did it this way, it is my way. I'm looping through each of these files, and then I'm just calling the executable, and then I'm specifying each file and changing the name. It is adding, right, one after another, and it is storing the path and everything there, and then I'm just ending. This is my way. I wrote this bash script, and if you have any other, even I can write the shell script. I have that one. Well, when I just run this executable in my Linux machine, because I have a lot of, okay, if I want to show you that one as well, because I have this data for many years, at least from 2003 to 2017. So what I was doing, I was trying to even do this thing. See here, I have the data, and let me just quickly show you that one, if it is possible. If I have access to that Linux machine, the server we have, okay, it should be there. Here it is. Okay, I don't need to go there. Maybe it's there. Okay, see the data I have here, and it's gonna be inside this data. Here you can, oh, not there. It should be inside XMRG, right? Can you see any XMRG there? It should be the data and XMRG. Where is that? Oh, HEC utility. It should be inside. Oh, I have all this script. It is not there. This one, data, inside data, it is not there. But I can tell you one thing, that it is this one. This data, Matagorda data. Okay, so inside that Matagorda data, because it is for that one, and then you have XMRG Precip. Okay, XMRG and Precip. You can see I have this data for this year, for 2003. If I just go inside 2003 003, I have this data for 1 year, means 8,587 data. See, this is for 1 year. This is for 1 year. And I have this data for 2004. I have this data for 2005 and all the way to 2017. So if I need to even process all this thing, I need a special script, right? That will loop through each of this directory, and then it will loop through each of this file, and then it will generate that .dss file. Then it was easy to import into my HEC-HMS model. But if I store all this data that covers the entire Texas or the West Gulf, right? So it is not even convenient to store, because my model is covering only this part. So why I'm just storing the other data that is basically unnecessary, right? So that's why I thought, okay, subsetting this data is the best way to proceed with my local model. So I did it, and now we can do that. So I thought it is pretty convenient to share my experience with you guys. So if you feel it useful, you can use that and you can practice, and let me know if you have any query or question, because watching videos is pretty simple, right? Other people are doing something that looks pretty easy, but when you are gonna do, then you'll face this problem, that problem, your code may not work, your computer may not support, there'll be different problem. So let me know, I'll try to help you with that one as well if there is any query, and just you can even suggest how can I improve future videos, and if you need any new videos based on different software packages related to water resources and hydrology. And because I have planned to even make videos time to time, and then if it is necessary for you, then I'll even try to do that. So thank you very much for watching my videos, and thanks for supporting my channel. Okay, so stay safe and take care. Bye.